inflation theory or cosmic inflation theory. This is the topic of discussion. So here, what is the problem? Problem is about Big Bang theory. The original Big Bang theory could not explain many problems such as the horizon problem, the flatness problem, the monopole problem. So many problems were there which could not be explained well by using the original Big Bang theory. So in the early 1980s, physicist Alan Guth and others proposed a theory which is known as inflation theory or cosmic inflation theory. And they became able to explain all the problems. Though this is not fully solved, still there are so many problems. Okay, but maximum of the problems were solved by Alan Guth and others, that team. Okay, and it happened in the early 1980s. So what are the problems? The horizon problem. This is one problem. Then the monopole problem is there. The flatness problem is there. So what is first I should discuss about what is the inflation theory. You know that just after the Big Bang, expansion of the universe occurred, and that occurred rapidly. Exponential expansion was there. Exponential. And everything happened within a fraction of a second. Yes, within that short interval of time, the main expansion process happened. Okay, so we are interested about that thing. Okay, so now, so Alan Guth solved according to his theory, and name of the theory is inflation theory. According to his theory, he could be able to solve many problems, but not all the problems. Anyway, let me explain all these things. First, I should concentrate on the horizontal problem. Sorry, not horizontal, it's horizon. The horizon problem. And other problems are there, those will be separate, those will be discussed in separate videos. Okay, in a single video, discussion of all those things are not possible. Anyway, so horizon problem. In this problem, this is related to temperature. Okay, you know CMB, cosmic microwave background radiation. That is afterglow of the Big Bang, and that is that snapshot of CMB is just 380,000 years old. Okay, that means the time gap between the CMB and the Big Bang is 380,000 years. So, how far distance light can travel within this time? Just you multiply the speed of light with this time period, 380,000 years. So, accordingly you would get the result. You know speed of light is 3 into 10 to the power 8 meter per second, and accordingly you will get the result. Anyway, now if you notice, if you observe the whole universe carefully, then you can see that the distances between stars are very much than that calculated value. That means within that time period, I am talking about the time from where we are getting CMB, cosmic microwave background radiation. By observing, by analyzing that CMB, scientists concluded that temperature fluctuation is almost zero. It is very small all over the universe. Okay. How much difference is there? It is just 1 part in 100,000 or 1 lakh. 1 part in 1 lakh. So small temperature difference is there. So if temperature, let us assume that, for simplicity, let us assume that temperature is uniform throughout the universe. That means transfer of energy took place during that time. How this was possible? How that was possible? Because I have already mentioned that the distances are much higher than the computed value. So for the energy to transfer, you know, maximum value is speed of light. So for energy transfer to take place, sufficient time was required. So how that was possible? That means the expansion occurred in a different way, different than which is stated in original Big Bang theory. So what was the idea? How inflation occurred actually? So let me again repeat the same thing, that inflation, the main expansion process occurred within a fraction of a second, and the expansion was exponential, very fast. Okay, so Alan Guth and his team or others, okay, they gave the idea that there was one field known as inflation field, high energy field. The inflation field is known as high energy field. When there was a transition from high energy field to lower energy field, so that field, that inflation field, released energy, and by using that energy, that cosmic expansion took place. That cosmic expansion occurred using that energy. Okay, and then when in a case of when it became lower energy state, when it reached to lower energy state, then the remaining energy converted into particles and radiation. What we observe today? Particles and radiation. But before that, the energy was used for the expansion process of the universe. So that means at present we can see that the distances between galaxies, stars are very much higher than that value, means 380,000 light years, because within that time period light can move that much distance only. But if you notice at present the distances between these large structures, then you can find that these distances are much more than that value. So according to inflation theory, initially they were at the same place, and during that place energy transfer took place, and that way the temperature of the whole universe became uniform. Okay, so that is the horizon problem. Okay, here horizon, the word meaning of this is different. Horizon means here the area or the distance in which light can travel within the given time period. So we are talking about 380,000 light years, 380,000 years. That means here horizon means according to that time period, what is the distance that was traveled by light? That is known as the horizon. So here observation is made beyond the horizon, and still scientists observe that the temperatures are almost same. So how this happened? So that was explained by this cosmic inflation theory. There are more problems. The flatness problem is there, the monopole problem is there, but those things will be discussed in a separate video. And what is still unknown today, that is the nature and properties of the energy inflation field is still unknown. Nature and properties, exact properties, are still unknown. One more problem is there. Many models of this inflation theory or inflation theory suggest that or proposes that multiverse exists. Means it is an ensemble of many universes, and in all the universes the properties are different. Okay, so inflation theory failed to explain this the theory of multiverse. Anyway, so problems are there. Scientists are still working on this topic. Okay. Anyway, so this was all about today's topic, cosmic inflation theory. Only one thing I have discussed in this video. Only one problem. The problem is known as the horizon problem, which is related to temperature. And I have mentioned that horizon means the distance, okay, according to the speed of light. Anyway, so this is the end of this video. Thank you. Thank you for watching this video.